boosting it.
Yeah. So those things are there, sir, and I think Gujarat has issued a special directives. So चल रहा है सर, अभी काफी कोशिश कर रहे हैं इसको, सुप्रीम कोर्ट ने भी
नहीं, with you are there, I'm sure fire services would be taking out the right interventions and the right processes which need to be implemented.
Thank you, sir.
General Bindal, we also have Dr. Yogendra Singh from IIT Roorkee. He's the expert on earthquake safety and earthquake professor there. He's also amongst us.
Good afternoon, Dr.
Good afternoon.
Yogendra
Good
Singh.
afternoon, sir. Good afternoon.
I can't see him. Dr.
Yes.
Yogendra. So
And,
you are with mechanical
I'm
civil
in
engineering.
Earthquake engineering. We have a separate department for earthquake engineering.
Okay.
So,
but earthquake engineering, isn't it part of civil engineering or structural engineering?
it has input with civil and mechanical, structural, as well as geotechnical from civil, and also the vibrations from mechanical, and also from earth sciences department, because engineering seismology comes from earth sciences.
Okay, so you have a separate department only for earthquake engineering.
That's the only.
This is the first ever, sir. This is the first ever. Late Professor Arya. Sir.
Okay.
So he established this new discipline, earthquake engineering.
That's right. I'm not in other IITs, when we do earthquake engineering, it generally comes under civil or civil, generally civil.
Civil people are working on earthquake engineering and structural engineering background mostly.
It is required. It has required. It cannot be. Everything has to be earthquake proof now.
We had this department started in 1962, and Professor Jayakrishna at that time, he started, and Professor Arya, Professor Paul, and we had done quite a few courses with NIDM, and especially with that SARC center. We used to do every year one course for SARC countries at Roorkee.
Okay. SARC has now shifted to Gujarat. And Gujarat Institute of Disaster Management, but we can do courses on earthquake engineering related with you. Professor Chandan Ghosh from our institute is so what we will do after this, I think you and Professor Chandan Ghosh, we are connect both of you, and let us start a series now.
Okay.
Since yours is such an old institute, I think there's a lot to learn from this department of earthquake engineering. And I've got two questions which I'll ask you later.
In fact, we have been in touch with Professor Chandan Ghosh and Dr. Amir Ali Khan.
And both of them are resilient infrastructure.
So we've been very fortunate to be in touch with, in very constant touch with Dr. Mahua Mukherjee, who's also the head of the Center of Excellence on Disaster Risk Management, Disaster Risk Reduction at IIT Roorkee, and she connected us to Yogendra ji also, and this is the exact line on which we were also thinking, because earthquake engineering is a dedicated subject being addressed by IIT Roorkee, and I think one of the subjects which we also look in very deeply during our conferences and training programs and e-conclaves, and you, as you rightly said, sir, if there is a series of such initiatives can be initiated with IIT Roorkee on earthquake engineering, and I think as an industry chamber we will be also very happy to collaborate and to partner and take this up forward.
We really look forward for that.
More and more industries to benefit out of this. So that is what we were looking at. Thank you so much again, Dr. Shami, and thank you, Yogendra ji, for joining us, and a big thank you to Ms. General Bindal and Anil Gupta ji, and of course Harshit from NIDM. Thank you so much for supporting us and working together almost like a partner, as we are partners, in putting this very meaningful webinar together, where we would be discussing on something very, very important: earthquake and fire safety in industrial establishments. It is in line with what we have been doing over the past 1 year, especially on creating resilient infrastructure in industries. I think that has been the core theme from where we started. And Dr. Gupta also briefly mentioned earlier that this is more like a an ongoing process. It's a refresher process which we need to adopt to reach out to more and more of our patrons, of our attendees who have been joining us over the past 1 year, to get them more information, more updated information. And it can't be two better resources than Dr. Shami and Dr. Yogendra on this subject, one on fire safety and the other on earthquake safety. While Varun, my colleague, is just trying to quickly reach out to General Bhardwaj, I think hopefully that technical issue which was there last time has been resolved. We checked with him earlier today, about a couple of hours back, and he could sign. So we can expect him to join us any moment, because we are we are already 10 minutes into the program, and without taking any longer, I'll just quickly take the audience through. We are already 200 in number, sir, which is a brilliant number. This particular webinar on earthquake and fire safety in industrial establishments is a joint initiative of NIDM and FICCI CIDM board. Today's agenda would be as follows. We would have a brief background lecture or a perspective setting by Dr. Anil Gupta, Professor and Head ECDRM, NIDM, Government of India. Then we will have the keynote and the inaugural by Major General Manoj Kumar Bindalji, Executive Director, NIDM. A special address and intervention from Dr. J.R. Bhardwaj, Lieutenant Dr. J.R. Bhardwaj, who is with us now. Thank you so much, General Saab, for joining us. A very warm good afternoon and welcome to you.
Thank you. Thank you.
After General Bhardwaj, we'll have the addresses by two addresses, or presentation, I should say, by Dr. Yogendra Singh. To begin with, Professor in the Department of Earthquake Engineering, IIT Roorkee, followed by Dr. D.K. Shami, Fire Advisor, DGFS, CD, and HG, Home Guards, Ministry of Home Affairs, Government of India. And at the end, we will take some question and answers from all the participants. So it is a humble request to all the participants who are joining us. Please put your questions, any questions you want to direct to this elite panel of speakers. Put it in the Q&A window, and we will take it up after the second presentation is done at the end of this session today, at the end of this webinar. So on that note, I would like to again welcome all the dignitaries, General Bindal, General Bhardwaj, Dr. Gupta, Dr. Shami, Yogendraji, colleagues from NIDM, FICCI, and most importantly, the participants who are joining us from all over the country and also from across the borders to this another one of the webinars in the long series of webinars we've already conducted in partnership between FICCI and NIDM. On that note, I would just quickly request Professor Dr. Anil Gupta ji, Professor and Head ECDRM, NIDM, Government of India, for his background lecture. Before that, I would just like to read out his brief introduction. Dr. Anil Gupta is a resilience and sustainability strategist who's worked for government, industries, and academia for over 25 years. Presently, he is the professor at NIDM and has steered several international and national projects of policy planning and research, and published over 25 books and 70 papers. He is a WMO expert team member on a climate statement, South Asia core group member of IUCN-CEM, vice chair of Association of Occupational and Environmental Health, and editor of Springer Nature book series on disaster resilience. In the past, he's worked with several organizations in the government: CSIR, NERI, DMI, NMDC, SciCon, state governments, and universities. On that note, over to you, Dr. Anil Gupta ji, for your background lecture. Over to you.
Dr. Gupta, you're on mute.
Yeah, thank you, Ruab. Respected General Bhardwaj, Major General Bindal Saab, the distinguished speakers of the day, Dr. Shami and Dr. Yogendraji from IIT, the entire team of FICCI and NIDM. This program, this particular webinar on issues of earthquake and fire safety issues within industry has been chosen after a discussion that we have already had a series of webinars. Then we converted the series of webinars into the three days online training programs. But online training programs are of 3 days, and sometimes there are some participants or some officials working in the industry. They had interest in these subjects but could not join because of the longer duration. It was not possible for them to join all the 3 days program, but keeping the importance of this subject and the kind of a interrelationship also, because many times earthquakes are followed by the fire risks also. And since in the recent time we are focusing more on multi-hazard approach in disaster risk management, this subject has been chosen. So I have 7 quick points to share from my side as a kind of a input to the discourse of the day. And I'm very hopeful that today's deliberation will be a very, very important piece of kind of a information sharing event. Very first thing is that when we discuss about industry, so in general, when we used to discuss about earthquake, seldom we discuss that earthquake risk in industry. So this is a kind of a paradigm shift that now within the industrial systems also, we are looking from other disasters rather than only chemical and the kind of a fire risk. And fire risk also, not only the chemical fires, but the fires of other kinds. So that is a kind of a paradigm shift that we want to bring in. Then a wide gamut of industry, maybe manufacturing, maybe power, maybe refineries, chemical, petrochemical, fertilizers, cement. But when we talk of industries, there are other establishments also which can come into the definition of industry when we talk about the earthquake and fire risk. For example, the effluent treatment plant, even the water treatment plants, or even the health establishments also, because many of the facilities, many of the subset facilities which are required in big hospitals are also like a kind of a medium type of industry. But why it is important that we discuss about earthquake risk for industries? So if we just have a look, I initially thought that I will bring a map, but somehow I could not bring that map. If we just look at the industrialization map of the industry in India, so industrial map, also look at the petrochemical map. If we look at the hydro, if we look at the thermal power plants map also, so we find that almost 70% of the locations where the high level industrialization is there are either zone 4 or zone 3 for earthquake risk. So this itself gives an indication that the locational dimensions of earthquake risk is very, very important in industrial risk management also. Then when we talk of industrial risk management, there are 5 important aspects. One is the infrastructure, that industries provide a major dimension of our infrastructure development, and lot of raw materials also, but also as an input output. So it is a continuous process that raw materials and other inputs are given, and there are kind of a supplies. So supply chain is another dimension. Then industries are also very important for employment. And the last but very important is the economy. Then there are certain past examples which make us realize that earthquake risk or other kind of disaster risk should also be discussed when we talk of industrial safety. For example, China earthquake. Although there was scanty information that came out, but now it is well known that the China earthquake has affected the chemical industries also under this impact. Then it was Bhuj earthquake also. A number of chemical industries and the underground chemical storages got affected. Orissa super cyclone, lot of chemicals got the vessels also got damaged during Orissa super cyclone. A similar kind of, but certainly different scale impacts have been observed near the Visakhapatnam area during the cyclone Hudhud also. Then certainly the Fukushima incident we cannot forget. Fukushima incident has shown us that we start discussing about the third type of disaster that we say that NATEC disaster. So natural disaster, technological disaster, but the natural induced technological disaster. So this is the category where earthquake can induce other kind of disasters within industry. So that is a kind of a situation of complex emergency that is very important. And therefore, when we talk of earthquake risk assessment, so 5 important aspects: seismicity, site assessment, structural assessment of buildings, then fittings and fixtures, and also the behavioral. And I think these are the dimensions we need to be integrated within the industrial risk management planning. And therefore, the site, even the issues like liquefaction, issues like the drainage, issues like hydrology, how it can affect the stability of the buildings in case of an earthquake. So these things emerge as very important. Earthquakes can be followed up by the fire risk, and fire risk is also aggravated because of the impact of climate change. Because in a recent study that we had carried out in some of the states of India, particularly Andhra Pradesh and Telangana, we found that the industries need to improve and modify their fire risk management system, looking to the changing threshold, looking to the highest temperature that now they face, particularly during the summer season. So that is a kind of additional risk. And then the fire is also associated with the lack of water supplies or the drought conditions, and fire is also associated as to lead to the consequences like pollution and also the accident impacts also. So these are very important things. And lastly, the earthquake risk management is also important in certain cases where industry itself is not affected, but the society, but the communities from where we are getting certain the ancillary facilities. Many of the industries are dependent on a number of wide variety of ancillary units located in the surrounding areas of that industry. We get not only small services, the additional raw materials, but also our workforce are the people who are employed in the industry. They are also living in those areas. So that is also important, that the earthquake safety in the offsite areas of that industry is also important. So it in nutshell, we can say that we need to evolve into more effective integrated risk management approach for the industrial areas where earthquake and fire risk emerges to be one of the important aspects. So with this thoughts, I'm very sure that today's deliberation will be very useful. And with this, I'm eager to listen to the keynote speakers of the day, and also to the learned speakers of today in this discourse. Over to you.
Thank you. Thank you, Dr. Saab. Thank you for setting the perspective, giving a background of what to expect in the in the next 1 hour or so. And I think we are all very excited as the participants are almost 215 number with us now. Really want to listen to some fruitful discourse and deliberations today. I would quickly move to to Major General M.K. Bindal, Executive Director, NIDM. For his keynote address, General Bindal has been leading NIDM, and also from FICCI side, General Bhardwaj is also with us. Both of them have really nurtured this entire platform to where we are today. Ladies and gentlemen, we'll have the keynote address by General Bindal. A very brief introduction. General Bindal. Yes.
I'll start. Okay.
Over to you, sir. Over to you.
Thank you so much, Rubab, for this opportunity. First of all, good evening, General Bharadwaj, sir. Seeing you after a long time. And this particular thing, if you remember, we started a year back.
Yes.
And in fact, the first program was done with Dr. Anil Gupta only, with the FICCI. And today we have reached a number of programs that we are doing. And this particular thing, we signed a MOU also. And I think we will carry forward this association and make that capacity awareness programs more and more meaningful. Today's topic is very, very important: earthquake and fire safety. Both are sometimes related and many times unrelated also, because earthquake is a event which comes or may not come. And fire safety is an event which often comes, and there are near misses. There are a lot of fires which are saved at the last minute, and there are actual fires which take place. So these two events today we are discussing, and we have two prominent speakers. One, Dr. Yogendra Singh, will be speaking on earthquake, and Dr. Shami will be speaking on fire safety. We were fortunate that previous speaker, Dr. Anil Gupta, spoke about the earthquake-related part of the whole series. So what I will do, I will not speak on the earthquake-related part. I'll speak on fire safety, so that between the two of us, we set the context to some extent. The fire at a cramped 4-story building, illegal factory in Delhi's Anaj Mandi, killed 43 people. It evokes memories of various fatal accidents that snuffed out innocent lives, often due to negligence. Similarly, a boiler explosion which happened at Unchahar, Raebareli district. It was run by government-owned NTPC. 43 people were killed and more than 100 were injured. Then we had that giant tank holding 8,000 kiloliters of petrol at IOCL in Jaipur, again in the evening. So the number of deaths were only 12, but hundreds were injured, and the repercussions were to follow for days to come. Thousands were evacuated after petrol fumes made breathing difficult. So it was only after 11 days that the raging fire, which had spread to adjacent fuel tanks as well and was causing loud explosions, was brought under control. And since 1984 Bhopal gas tragedy, we have seen significant industrial accidents that have resulted in the loss of numerous lives. The most recent incidents we have seen, Vizag industry, then two very similar incidents took place the very same day in the nation, it posing serious questions to the aspect of industrial safety in the nation. NDMA, National Disaster Management Authority, it noted in a report that very few full-scale drills of district off-site emergency plans are being conducted in the country. And even those are not conducted as per norms. Perhaps the 3 industrial accidents in one single day may hasten the plugging of these gaps, which was pointed out years ago. India today is developing as a key global player in the industrial and technology sector. Rapid industrialization has increased the hazard, the risk, and the vulnerability to the industry and the environment. Chemical being at the core of modern industrial and production system, the risk of accidents involving chemicals has attained a very serious concern for disaster management within the government, corporate sector, and community at large. I remember during the Bhuj earthquake, there are more than 400 chemical tanks in Kandla airport. So the biggest scare that we got, because Anjar was devastated, Bachau was devastated, and they were very close to those where this tankage area was there. Unfortunately, except for one tank, there was no leakage from any other tank, and that could be controlled at point of time. Just imagine at that point of time, those 400 different types of MAH would have exploded or leaked out. What would have been the additional casualty rate in 2001 earthquake of Bhuj? Industrial disasters, they are low in frequency, but are very significant in the terms of loss of lives, injuries, environmental impact, property damage, and socio-economic implications. Frequency and severity of such disasters has increased in the few years due to the rapid development of industries of wide range, such as manufacturing, formulation, petrochemicals, pharmaceuticals, agrochemical fertilizers, pesticides, industrial chemicals, and then store facilities that store such hazardous chemicals, oil depots. The list is endless, plus the transportation, the carriers in densely populated areas. So these have posed the greater risk and vulnerability for such disaster likeness in future. At the state level, the State Disaster Management Authority, Department of Factories and Boilers, Industrial Health Safety, Labor Department of Health, Environment, Pollution Control, they and many more. Every state has got a difference in the number of departments which look after. They're directly responsible for the disaster response. However, there is a visible gap in understanding and coordination among various agencies. And disaster prevention mitigation and disaster response related organizations in the context of the industrial disasters. So there's a need to work out better and effective institutional mechanism, coordination and strategies for ensuring synergy in the various activities of different ministries and organizations. The causes of industrial and chemical hazards and the disasters are malfunctions, failures, unanticipated side effects of the technological system. But this is misleading oversimplification, but there are many more factors which are involved. So the number of factors which can trigger industrial accidents are process and system failures, safety system failures, natural calamities, terrorist attacks, hazardous waste processing or disposal. There are more than 1,894 major accident hazard units in the country. And there are several millions of registered and hazardous factories below MH criteria and unorganized sectors dealing with numerous range of hazardous material posing serious and complex levels of disaster risk. So offsite preparedness of a disaster management needs multidisciplinary inputs and interdisciplinary coordination, effective information processing and management systems, and integration with the holistic multi-hazard disaster framework along all stages, starting from hazard risk assessment, prevention and mitigation, preparedness, response, relief, and rehabilitation, and within the broader framework of planning and development at local and regional level. We have, I'll say, two major cycles for a disaster. Well, first is hazard and risk mitigation, and second is emergency management and post-disaster relief and rehabilitation. The government industry community interface, it plays a very major role in this offsite risk management and in responses during emergencies. It includes the role of various services and subject experts ranging from geologists, meteorologists, hydrologists, GIS-based, land use, regional planning, law, jurisprudence, and many other stakeholders are there. And this is different from the core focus of the on-site disaster management plan that mainly focuses on environmental system, the processes, the incident control, the fire, controlling of the fire and fire procedures, occupations, health and safety, first medical response and medical care, then transport and control system. So to strengthen the industry safety in the country on a sustainable basis, we should have an approach which could include the preparation of the action plan, implementation and coordination at the national level, institutional mechanisms and coordination at state and district levels, district level to community level preparedness plan and appropriate linkages with state support system and financial resources for implementation. Thus, in nutshell, a thorough participation of all stakeholders, including local communities for on-site and off-site emergencies, will ensure management of industrial disasters, both earthquake and fire safety, can be dealt with more effectively. So with this, I will finish my keynote, and I'm keen to hear the two renowned speakers who will be speaking on the two issues. Thank you so much. Over to you, Ramon.
Thank you so much, Bindal, for that very visionary, I would say, keynote address. And you've touched upon some very important points, including development of institutional mechanisms to deal with all of these issues. And I think there are several issues. It's a huge domain in itself. And I think more and more training, more and more information, more and more dissemination of valid information is what we need. And as you said, capacity development is the key to be better prepared and to mitigate the risk. Thank you so much, General Bindal, for your address. Now, I would now request and move on to Lieutenant Dr. J.R. Bhardwaj for his visionary special address. General Bhardwaj is the chairman of CIDM board at FICCI and former founding member of the National Disaster Management Authority, Government of India. He's also the honorary surgeon to the President of India and was appointed on 27th September 2005 to the coveted post of member in the NDMA. an appointment accorded status of Minister of State in the Government of India under the chairmanship of Honorable Prime Minister of India. Prior to the appointment, he served as the Director General Armed Forces Medical Services, DG AFMS, the highest a doctor can achieve in the Indian Defense, in the rank of Lieutenant General in the Indian Armed Forces. On that note, I would now humbly request General Bhardwaj for his special remarks on this subject. Over to you, sir.
Thank you, Rubab. Good afternoon, everybody. It's very nice to be mentioned in the long gap. Hope you're absolutely healthy now. And always thinking of you when you are during his webinars. And Professor remains the keynote, always main speaker, oral speaker, opening batsman. I would say also, and process of webinars. Young and without and hard work, we cannot carry out these kind of webinars. It's a great the FICCI and NIDX to out very important issue for us, which are really very important, not from today point there, but right from the day one when the industry was to establish. I get reminded of when I joined NDA, one of my first was to a nuclear plant because chemical industry by definition includes nuclear plants also. And we have a number of nuclear plants all over the country. Their vulnerability and their pose, it is huge. So I told customer risk and your development will include those on the atomic energy plants so and other atomic plants. It was really when that time really got not seen energy plant and not even plant and proper expansion of our for to United States Prime Minister we are progressing our I want to narrate and try the so when they the round of the park plant the very vital areas and but I think actually was really know how strong has made their plants and have indicated all vulnerability. One of the things which I asked generator highest in that is a big area, and there is a kind of thing. The generation are product based on the ground. The electricity was from a very high. I said, why you look up the generation at high? All naturally. If precipitation to tsunami, 50 feet of the wave, that water wave, and destroy the plant, take a stop the cautions. So, I 2 years back, we had a disaster in Japan. And followed by a tsunami and followed by affecting a large number of very large number of people. And when our one of us were on with him, later on briefed us that one of the reasons of this incident, because that failed, the India gets heated and then goes beyond the temperature control, then it that cool to have of the of electricity. I could then do that back up and stuff like this in these plants. I could understand our point, thinking of earthquake, thinking of tsunami, thinking of natural disasters that should not affect plants, which can be improving, which may be dangerous and very on the plants. I don't know. Who must be was doing the design that was and also. So, as Professor Gupta had said, that though there is enough to place and bring out in areas least affected by, but the history of almost every place has a history of new plant, you have to think of setting up a plant. When we were working on the national guidelines, one of the we started from all permits the plant to be put in the ecological survey from all those things have to be first analyzed. Then so natural disasters become very important as far as we can't isolate it or any other that not in this. So we think without thinking of the natural disasters and disasters. And then has pointed out that of any disaster sector of chemical industrial plants is the fire, and whether it's sector, whether it is hazardous. So fire management and fire preparation to prevent, I would say, not tackle. Prevention of fire is one of the important things. As part of the on-site plan and part of the off-site plan, it is a very important segment of both the plans. We carry out the on-site drills by the plant, off-site plan together, which everybody is supposed to twice has to see that what are the capabilities, what is this question of fire and get by one of the SE in Madhya Pradesh. Is a big area. And we go a plan. Our will be conducted at about bottling plant. So next to bottling plant was a factory.
So we are losing your voice, sir.
making ready. Hello? Can you hear me?
Yeah, we were losing your voice, sir. It was cracking a bit. Now we started to lose your voice. So can you switch off your cameras for a better bandwidth, sir, so that you may please turn off your camera to get better bandwidth, sir.
You hear me now?
Yes, sir, we can, sir. Yes.
Can you hear me now?
Yes, we can, sir. We can hear you.
Okay. So next was which was in the ready clothes for export. And in that almost that cloth for ready-made garments. Try to see that the havoc and the terror that spread in the plant. Listen to it plant who is for the who defended us, of course. That happened 2 years, but still to my surprise, the and so how important is the plant should see that something of a chemical in examples like that, where one has to think about the cycle of plant to get the complexity of the chemical plant, which you will be if may practically about this according to the laid down rules, and the people who are working on may educate, but at least what is their duty when they and safety is a very big issue on which we have conducted webinar. Very sure this webinar also on various aspects of industry and fire safety, the chemical industry, in particular, and the preparedness to meet any eventuality that may affect the chemical industry. This is what I thank you, Rupa, and all for kindly continue. We are still, and this and great institutions carrying on its progress as well own chart duties.
Thank you. Thank you, General Saab. Thank you so much. That was the ladies and gentlemen, Dr. J.R. Bhardwaj, stating some very, very key examples from his personal experience also where he's visited. He was someone who's been who was very closely involved in the relief and rescue work during the Bhuj earthquake. You know, he's seen some most of those things on ground, and has been was one of the key front line leaders of our country in that effort. So thank you so much, General Bhardwaj, for sharing your experience, sharing those very critical points on fire safety and as well as on earthquake safety. Ladies and gentlemen, now we would quick move on to the first speaker, the eminent speaker of the day, Dr. Yogendra Singh, who is a professor at Department of Earthquake Engineering, IIT Roorkee. Performance-based seismic design, performance-based design of buildings and bridges, seismic response evaluation of structures, non-linear modeling and analysis of RC structures, seismic evaluation and retrofitting of structures, and most of those things related to seismic fragility analysis of hill buildings, seismic risk in hilly areas, and so much more is the area of expertise of Dr. Yogendra Singh, a very awarded and a decorated career. Sir Arthur Cotton Memorial Prize in 2011, Dr. Jayakishan Prize and Medal Institute of Engineers at IIT Roorkee. He was awarded this award in 2008, Outstanding Teacher Award, and many more to his name. On that note, I would now request Dr. Yogendra Singh to take over from here for his presentation on earthquake safety.
Thank you, Mr. Sood. I think I'm audible. I will share my screen. And yes, it is visible.
Yes,
okay.
it's clear. Yes.
So thank you so much. I'm grateful to FICCI and NIDM for giving me this opportunity. And I'm also thankful to all those who have joined. A very good afternoon. And the topic which I'm going to talk about is earthquake safety in industrial establishments. So let me first show you what an earthquake looks like. So this is a record of an earthquake. We also call signature of an earthquake. So this is a record obtained from the instrument, what we call accelegraph. So the record is called accelerogram, and the instrument which records it, that instrument we called accelegraph. You might have heard about seismograph, and the record is seismogram. So second one, the middle curve here, middle plot you have, that is a typical seismogram. So actually this accelerogram is nothing but the record of ground acceleration, and seismogram is the record of ground velocity. And this acceleration gives us a clear idea about how the earthquake force is varying with time, because earthquake force is an inertia force. We have learned that much in our 10th physics, that when we are standing on a bus and suddenly the bus starts moving, we feel like that somebody has pushed us backward, but actually there is nobody. So that was just a feeling. A similar feeling all our structures are also having during earthquake, when the ground suddenly starts moving and the structure, due to its inertia force, due to its property of inertia, experiences a fictitious force. So earthquake has a fictitious force effect on all our structures. Then there are some very peculiar characteristics of earthquake. One characteristic which you can see in this graph is that it is changing its direction. It is a reversible type of phenomena, which is changing its direction in a fraction of a second. So total duration of earthquake can vary something like 30 seconds to 1 minute. That's the typical duration. But you can see within that duration, it is changing its direction several times. And this change in direction is a peculiarity of earthquake as compared to other actions which we have on our structures, like gravity, which is always acting downward. It doesn't change its direction. And wind load, which is a fluctuating type of load. It's causing a fluctuating pressure on the structure, but it's not reversing, at least not in such a small duration. It may take hours or days to reverse its direction. So that makes earthquake very different than other actions which we are having on all our structures, including industrial structures. The other characteristics of earthquake are that it is a very rare event. That's another issue with earthquake. I don't know whether it is good or bad, but it is a very rare event. And when we are talking about earthquakes, we often talk about a term called MCE, maximum considered earthquake, which has a average return period of 2,500 years. So a big one, a large earthquake, we are expecting at a particular site at an average return period of 2,500 years. So that gives you an idea that how rare this event is. And when we are using for design, we are calling an earthquake what we denote as design basis earthquake, DBE, which is having a return period of 500 years. So we are usually designing for 500 years. We do not design for 2,500 years because that is a very large event and it has very severe impact. So we cannot design, it is not viable for designing for that 2,500 years. We design for this DBE, which has a return period of 500 years. But we expect that when we design for this 500 years, then our structure will not collapse. It may be damaged badly. It may not be able to resist that earthquake without damage, but it will not collapse, because collapse will lead to a chain of events and large scale loss of life. So that is avoided. But it has a very severe impact. And this impact is on economy. We will see with some figures that how much severe this impact can be on economy of a country. And this impact of earthquake force is so large that no damage design is uneconomical. We always design, even with our latest code, when we are designing, some damage is acceptable, some damage is accepted, because the cost of construction will be much larger if we are going to design our structures not to get damaged. Only for very special type of structures like nuclear plants, there we can go for no damage structures, because the damage can have really very hazardous consequences. But other structures we always design to get damaged. And as I discussed, this reversible nature of earthquake, that makes it unique, and it sets a vibratory motion into structure and components. That is helpful to us, because if this acceleration which is occurring during earthquake, if it was acting in one direction without reversing its direction, then design would have been impossible. So we are able to design our structures for earthquake, that large forces, only by the virtue of this reversible nature. And there is another aspect of this vibratory motion, that is the earthquake is imparting some energy to our structure. And somehow, if we can dissipate that energy, then our structure can survive that earthquake. Because if we are not helping the structure in some way in dissipating that energy, then the structure knows only one method of dissipating energy, that is damage. So energy is dissipated by movement of the structure, the cracking of different components, then friction. So that's how the energy, the kinetic energy which is given by earthquake to the structure is converted into other forms of energy, or what we call energy dissipation. And as a consequence on structures, we have this type of scenario. So in 2000 Bhuj earthquake, in several structures, we had this type of phenomena where the structures have collapsed. Not only in India, Bhuj earthquake, in other parts of the country, Japan, which is well known for seismic resilience of its structures, there also the failures, even in recent years, this type of failures have occurred. And there are many examples of such. Another example where the structure has failed. And interestingly, all these structures are made of steel, and steel is said to be very good, very ductile material for earthquake safety. Still, the damage is unacceptable. So this level of damage we do not accept in our structures. So even in Europe, which are not that seismic, for example, Italy is one of the countries in Europe which is seismic. So in 2012, there was widespread damage in northern Italy in industrial structures as well. What is the reason for this damage? What is the most common cause? And the cause lies, although our structures are made of steel, but most of these structures are what we call concentrically braced frames. So I'm sorry to introduce a small technical term here. So these concentrically braced frames, which we commonly use in our industrial structures, so these are having this type of braces, these diagonal members in our structures. And these diagonal members are supposed to resist the earthquake force during the event. And these are subjected to reversible compressive and tensile forces. And as a result, either these buckle or these fracture. This fracture of these diagonal braces, that is responsible to most of the damage in our industrial structures. And later on, we will see that how we can take care of that once we understand that this is the most common cause of damage. Then another cause of failure have been the precast construction. So precast construction has several advantages in terms of quality control and speed of construction, but at the same time, it is very prone to, very vulnerable to earthquake damage. And the reason is the joint. So as we can see in this photograph here, the joint between the precast elements, this is usually a cold joint. So there is no positive connection between the two components. One component is simply resting on the other. And when the earthquake sets this structure into vibration, then there is relative movement. And as a result, the components fall down. So those components which are not properly connected. So in these photographs, we can see different components, the beam, the cladding, and the whole structure itself has fallen down, and only columns are standing here. So that type of scenario has been observed in case of precast construction, and we need to have special precautions in this type of constructions. Storage, liquid storage tanks, those have been susceptible to earthquake damage. Buckling of the shell of the tanks. That has been a very common damage during earthquakes. Then industrial structures especially are having a lot of non-structural components, a lot of fittings, pipings, and equipment is there. And that is also prone to damage due to earthquake. So even if our structure is intact, even if the structure has behaved nicely during earthquake, the damage to the non-structural components is one of the regions of failure. And so far, even our IS codes do not cater how to design, how to fix our non-structural components properly so that the damage during earthquake does not occur. So this is a relatively recent and less developed science that how we can make our instruments, equipment, and pipings safe during earthquake. This is also in reference to, as one of the previous speakers talked about, hospitals. The hospital is also like a small industry, a medium-sized industry, and there are also a lot of non-structural components are there, and we have to take care of these non-structural components also, which are usually not taken care of in our typical conventional earthquake-resistant design. And this type of damage has been observed in past earthquakes, which may or may not be cause of life loss, but it is definitely a big source of economic loss, and the functional loss, production loss is there. And pipings in this are particularly prone because pipings are connecting one component to the other component or one equipment to the other equipment, and the two equipment during earthquake can move relative to each other. And when these two equipment or two components of a structure are moving relative to each other, piping is subjected to large forces, and as a result, the piping rupture. So a common type of failure has been seen in past earthquakes, including Bhuj earthquake, that the piping has failed. Even the pipelines, which are running from long distances from one point to the other. For example, this is a port structure during Bhuj earthquake. So on the port, these pipelines have failed, those have fallen. The long pipelines, the water, sewer, and gas pipelines, especially in our gas and oil industry, we have long, sometimes cross-country pipelines. And those pipelines are subjected to a variety of actions due to earthquake, mostly due to movement of the soil, because during earthquake, the soil also gets vibrated. And as a result, there is movement in different directions. There is vertical movement, horizontal movement, and even the longitudinal movement. As a result, the piping, we can see that the pipes bend, the alignment of the pipelines gets changed during earthquake, and as a result, the pipelines are subjected to very large forces, and many times those break or cause leakage. Then there are many secondary hazards which are triggered by earthquake. One such hazard is liquefaction. So liquefaction happens in case of low-lying areas where the groundwater table is high and the soil is loose. So earthquake shaking causes the soil to lose its strength. And when the soil loses its strength, it behaves like a liquid. And anything which is resting over it either sinks or gets tilted. What we see here, that this large tank has tilted. And if that type of tilting is occurring, we can imagine what will happen to the interconnections of these tanks. Then fire. This has been pointed out by other speakers as well, that a very common phenomena, especially in industry and there too in oil and gas industry and hazardous chemical, inflammable chemical industry, the fire, it has been observed in many parts of the world. So devastating fires have been seen after earthquake. So what you see here, this is an oil storage facility where one of the tanks is burning after the earthquake. And it becomes very difficult once this type of phenomena happens after earthquake. And even the water supply to extinguish the fire and the communication lines may also be not available. So this becomes a very dangerous situation, secondary phenomena which has been triggered by earthquake. So another photograph after this Tohoku earthquake, which was really big one in Japan. So a oil storage and gas storage facility, it has been devastated due to fire after earthquake. Then tsunami is another, and this 2011 Tohoku earthquake proved that although it's a very, very rare phenomena, earthquake itself is a rare phenomena, and not all the earthquakes are going to cause tsunami, but its impact on our society and economy is tremendous. So here we see one oil storage tank, which has been not only damaged but moved away by the tsunami, and no structure can be designed against such type of forces if these are unleashed by an earthquake event. Now, what impact it can have on our society and economy? So here I'm not showing the life loss. You may be familiar with what has happened to life loss after these big earthquakes. But here is the data of economic losses, and that direct economic losses. So earthquake losses, or for that matter, any hazard losses, we can divide into two parts: the direct economic losses, which are happening due to the direct impact of the event, and indirect economic losses like the loss of production, loss of the employment, loss of the market. So all those comes in the indirect losses. Even the direct losses, if we see, so here the general loss is perhaps not that much, but you see these spikes in certain years, and each spike corresponds to what we call a great earthquake. So the Great Kanto earthquake, which happened in 1920s, and most recently this 2011 Tohoku, Japan earthquake. Perhaps it has the highest impact, as large as $75 billion US. That much was the direct economic loss, and we can see that approximately same is the order of indirect losses. So the effect of this event is really large. So it is a rare event, but whichever years it occurs in a particular country, it has the potential to destabilize the whole economy of that country. So we have to take care of such things. So coming to the average loss due to an earthquake. So here for the last 112 years, there is a collection of average annual loss. So in terms of GDP, so if we see the color in which India is shown, it's somewhere here, so 0.02 to 0.03% of GDP. So it may not appear to be very large when we are talking about the average on a year, but it is not occurring in every year. It is concentrated in some year, in that particular year where it occurs. Its impact is really large. So if I compare the direct and indirect losses, so for the past earthquakes, it can be seen that the line joining the direct and indirect losses is almost at 45 degrees. That means the more or less the direct and indirect impact of an earthquake in terms of economic losses is same. Almost same order of indirect losses are also associated with the direct losses. And different causes, the secondary hazards which are triggered by earthquake, those are also having about 40% impact. So here we see this green, light green color. This is showing the impact of shaking. So due to shaking, there is roughly 60% of the total loss here. This is the total loss, and this is the direct loss. So in direct loss, the component of shaking is more, but in the indirect loss, the component of other secondary hazard, that significance of those hazards increases. So together with tsunami, landslide, liquefaction, fire, and NatTech. So natural hazard, that is phenomena, that is earthquake, in this case, leading to other technical hazards. So together, this is also quite significant. So it is not only the shaking which is causing economic loss, the other secondary hazards are also having significant impact on the economic losses. Just to give an idea, during the Gujarat earthquake, actually the Gujarat earthquake of 2001 was the first earthquake in India which has affected a developed or urban area. Before that, the earthquake like Uttarkashi or Chamoli and Bihar, Nepal earthquake mostly affected rural areas and low developed economies and economic areas. But if we talk, I mean, this earthquake, 2001 earthquake, and here if we see the relative loss contribution of different sectors, industry, of course, the maximum loss came from housing, but the industry was also at the third place. So industrial loss was also large. So it was third only after housing and trade and commerce, which was indirect secondary loss, but industry suffered a significant direct loss as well. So what to do? Now we understand that what earthquake does to our structures, including industrial structures, and its impact on our economy. So what can we do? So let's see that what safety measures we can have, particularly in case of industrial establishment. The main or the first step which we have to take is regarding our current earthquake resistant design practice. So this chart shows the current design practice, which we also call prescriptive design practice. So far, the codes, the earthquake standard design standard codes like IS 1893 and IS 13920, which we have in our country. So those codes are based on the prescriptive provisions, which are based upon the experiences during past earthquakes. So here, when this code was revised in 2002, we tried to get a realistic estimate of the hazard. So this top blue curve, it is representing the hazard. So we try to get as realistic estimate of the hazard as possible. But we do not do the realistic estimation of our structure. That's the problem. So we reduce this hazard by a factor R, which we call response reduction factor, and we design our structure for this reduced force. And we apply certain factors of safety. In fact, that gives a false idea to our designers that there is some factor of safety, but actually there is no factor of safety. So we reduce this hazard by a factor of about 10, and then we design our structures only for 1/10 of the force which will be actually being applied during the earthquake. Naturally, when we are designing for this low force with a factor of safety of roughly 2, is still our capacity, which is given by this green curve, green curve here. So that is still 1/5 of that force. We are designing for much lower earthquake force, and the understanding behind this philosophy, this method of design is that during earthquake, we will accept the structure to undergo damage, but that damage will be controlled in such a way that the structure will not collapse. So we are ensuring that the structure is not collapsing. And we can see that from the forward of our code, especially in 2002 version. So it was mentioned that as far as possible, structures are able to, so when we are designing our structures as per the code IS 1893, and our industrial structures are also covered by the same code. So the intention of the code is that as far as possible, structures are able to respond without structural damage to shocks of moderate intensities and without total collapse to heavy intensities. Now, this is intention. This is intended in the code. There is no framework to ensure that. And that too is written in very vague language, that as far as possible. So it is not in quantitative terms, that whether we will be really able to achieve those or not. And without structural damage in case of moderate intensities, and without total collapse in case of heavy intensities of earthquakes. But because the code is lacking a framework to ensure even this, so when the code got revised recently in 2016, then this paragraph was also taken out, and only one line is written here, that structures designed as per this standard are expected to sustain damage during strong earth shaking. How much damage? That is also taken away because there is no framework. So if I ask that, is this practice satisfactory? Clearly the answer is no, it is not satisfactory, and we have to look for a better design practice. And that better design practice is given by performance-based design or risk-targeted design. So these are the two approaches, future approaches, which we have to incorporate in our design codes as well as in our industry. So there is already work going on performance-based seismic design, and hopefully soon it will come in our IS 1893. But we have to go beyond that also to have risk-targeted design, where an owner can plan that how much risk he or she is willing to take in the event of an earthquake. So this, in a simplified term, I can explain what performance-based design is. So in performance-based design, we estimate the hazard, that is the intensity of the earthquake also, as realistic as possible. And in addition, we also estimate the capacity of our structure. And then we try to compare the demand, that is the hazard, intensity of the earthquake, with the capacity of the structure. And then we can decide that how much damage is going to occur in my structure if this particular earthquake is occurring on this particular, is affecting this particular structure. So we know that this is the damage. And then I can decide whether this damage is acceptable to me or not. If it is not acceptable, then I can improve the design of the structure. So this is performance-based design, but still it is also in deterministic terms. So this can be extended further in the probabilistic terms, and where we estimate our hazard as well as performance of the structure in probabilistic terms. So the technique for estimating hazard we call probabilistic seismic hazard assessment. And as a result of probabilistic seismic hazard assessment, we get a uniform hazard. What is meant by uniform hazard? The uniform here is the probability of accidents. We get a uniform probability of accidents. For example, in case of maximum considered earthquake, MC, the big one, 2,500 years return period, which we talked about, that is having a 2% probability of accidents in 50 years. So 50 years is in engineering community, that is the typical design life of a structure. So in the design life of a structure, there is 2% probability of being exceeded. So we can have some idea that what we are expecting from our structure. Then this also doesn't give me any idea about how my structure is going to behave. It gives idea only about the earthquake, that stronger than this earthquake can occur only for 2% chances in 50 years. So we have to go for risk targeted hazard. In fact, in ASC7, the American code is the only code which has adopted this methodology so far. So there now the hazard is not expressed in terms of probability of accidents. Rather, it is expressed in terms of probability of collapse of the structure. But when we are saying a structure, then different structures have different characteristics. So here a standard type of structure is defined, and for that structure, ASC7 defines MCER, maximum considered earthquake risk targeted, and it targets a 10% collapse risk at MCR. So there are 10% chances if we are designing our structure, even with this latest code, we accept 10% collapse subjected to occurrence of that MC. But please understand that doesn't mean that 10% of our structures are going to fail, because it is conditioned to the occurrence of that MCER. So we have corresponding to this the risk targeted design of the structure also. And whether with this risk targeted hazard and risk targeted design, ASC7 targets to achieve 1% collapse risk in lifetime of a structure. So any structure has 1% probability of collapse. And if we have that type of design available and that type of estimates available for our industry, it will give us a better idea of the planning. And in fact, the insurance will also be possible, because currently the biggest challenge against insurance is the earthquake incidence is that the chances of collapse or failure or damage of a particular grade in my structure are not known. So these insurance companies are working on some models, but many times the earthquakes prove those models to be wrong. And in that case, the insurance model doesn't work, and the companies become bankrupt. Then there are some techniques, simple techniques, which we can achieve to improve the performance of our structures, especially industrial structures during earthquake. I talked about this diagonally braced, centrically braced frame, which is the main reason of damage during earthquake. We can replace this by this type of eccentrically braced frames. So here these braces are eccentric, and this is designed especially in such a way that the damage does not occur in the structural components, rather occurs in this small link in the center, you see, or at the corner. There may be a small link, and this link is bolted to the structure. All the damage, energy dissipation will be taken by this link, and this link may get damaged badly during earthquake. So the repair after that earthquake is also easy, because this link can be simply bolted out and removed and replaced. So that gives the ease in replacement and repair after earthquake, and it localizes the damage in the structure into that link. So that is one very promising technique which we can use in our industry. Then similarly, in case of precast structures, the main problem was the integrity at the joints. So if we can ensure the integrity at the joints, we can avoid damage in many cases. So many techniques, many details are available here. I will not go into the details, but those who are interested in this or having civil engineering as their profession, they can look on internet. Many details are available where positive connection between the components is ensured, that during earthquake, when vibrations, the shaking is occurring, the components do not fall down. So number of such details are available. We can help our structure in dissipating the energy. So we can have in our structures what we call dampers or energy dissipators. As I said, that earthquake is imparting energy to our structure, and the structure has to dissipate that energy at the same rate. So our structure should have a capacity to dissipate the energy at same or higher rate. Then only it will be able to survive that earthquake. And structure in general knows only one way of dissipating energy, that is through damage. So some damage, some cracks have to occur in the structure so that there is friction, there is loss of energy or conversion of energy from one form to another, to heat. So that's how it can dissipate the energy. Alternatively, if we help the structure in dissipating energy, then the structure will not have to damage itself to dissipate energy. So this concept is based on this understanding, and these dampers are very similar to the shock absorbers which we have in our automobiles, trains, and many other industrial applications already. So these, if we provide at proper place with the proper amount and proper size, then we can dissipate the energy with the help of these dampers, and then the structure will not have to undergo damage. And many principles are now used to dissipate energy. One is the viscous fluid, the common type of the dampers which we have in shock absorbers in our vehicles. Here we have a friction type of damper, where when this building will start moving, so this system will rotate, and these plates, number of plates we have, these plates will rotate with respect to each other, and the energy will be dissipated during this rotation against friction. So the kinetic energy will be converted into heat, or what we call that the energy will be dissipated. Then in case of machinery and tanks, we can also have the base isolation. So those sensitive equipment which can get damaged due to intense shaking during earthquake, we can put on flexible elements. These flexible elements we call bearing, and the purpose of this bearing is that when the ground moves, the vibrations are not transmitted to the structure, and when the vibrations are not transmitted to the structure, it does not have to, that energy is not transmitted to the structure, so it does not have to dissipate that energy, and as a result the structure does not get damaged. So this is another technique which we can use to safeguard our, at least the sensitive equipment. Then cross-country pipelines. This is one example, Trans-Alaskan pipeline. We know that this is the most seismic area of the world, the Alaska region, and this pipeline is crossing an active fault. So here the pipeline has been designed and constructed in such a way that during earthquake, even if there is a movement, a lateral displacement occurs at this fault, the pipeline can absorb. So in case of pipelines, flexibility is the key. So if we make the pipeline flexible, and this shape you see, it is not in a straight line, this is zigzag. That's also intentionally done like that, because the movement can be in any direction. So even the length of the pipeline should be such that it should be able to accommodate. Suppose there is a movement in the longitudinal direction, then there should be some extra length available which will be able to accommodate that movement without rupture of the pipeline. And at the same time, this is on the sliding type of arrangement. So here is a sliding arrangement. This Teflon shoe is there, which is reducing the friction, and as a result, it will be able to move during earthquake in the sideways direction. In case of our piping within the industry, such flexible joints, these are important. So such flexible joints can take care of these can absorb the movement which may be occur between two components. So two components of any industry during earthquake, when those are vibrating, they may move relative to each other in different directions. So such connections which can accommodate these movements in different directions are the key to safeguard. So here you see a loop has been made. Again, the purpose is that when the movement occurs, the building structure itself will move, the component will move, the ground will move. All that movement can be accommodated. Here there is a combination of two skills. One is the flexibility provided to the pipeline, and another is that here with these springs, you see there is a controlled friction here. So during earthquake, if the intensity is more than or higher than a particular threshold, then this pipeline will start vibrating. And when it is vibrating, this sliding shoe on this steel arrangement, that will dissipate energy through friction. And we can control through the force in these things, that at what force we allow our shoe to slide. And the sliding is the process which is dissipating the energy through friction. So these are the techniques which we can take up at the local level, and the philosophy of earthquake resistant design, which we are currently following, which we call as the prescriptive philosophy, which is based on do's and don'ts. And most of our designers are not happy because that puts so much restriction on their design practices. So we go, or we should look forward for more advanced design philosophies. Of course, those will require better techniques. So in case of analysis, and these will require better tools for nonlinear analysis, but we can achieve better performances. So thank you very much for your hearing. And whenever there will be slot for the questions, I will be happy to take up your questions. Thank you again.
Thank you. Thank you so much, Yogendraji, for that very, very informative, pleasing to the eye presentation, I would say. Some very well detailed slides you had mentioned, starting with the examples of Bhuj, the Tennant Creek, Chokachioki, some critical earthquake scenarios you took up. And most importantly, all these earthquakes were around a cluster of industries. Like in Bhuj earthquake in Gujarat is the leading the most industrialized state of the country. So that adding that perspective to your presentation, how seismic safety of industrial structures is important, and the structure dissipators, the idea of dissipators, and I think something which has been very widely used in the industry, and something which should be more extensively used in times to come. I think to make these industrial structures more resilient to earthquake situations. I think it was very well received by all our audience, and they've been really praising your intervention. Thank you so much, Dr. Yogendra. And I would suggest all the participants who are interested to ask any specific question, please mention your questions in the Q&A window, and we'll try and take as many as we can at the end of the session. Moving on, thank you so much, Yogendraji. Moving on now, Dr. Shami, thank you so much, Dr. Saab, for bearing with us. We are really, apologies to both of the key speakers. We are running behind schedule, but I will not take long, and I would not be between you and the knowledge you are going to share with and the audience. Ladies and gentlemen, Dr. D.K. Shami, Fire Advisor, DGFF, CD and HG. HG is the Home Guards, CD is the Civil Defense, Ministry of Home Affairs, Government of India. Professional experience, 35 years in industrial, state and central fire services, including advisory role in Government of India. Professional achievements include being the chairman and member of BIS committees, member of OISD Standing Committee, which is the executive agency in the Ministry of Petroleum and Natural Gas, Member Secretary of Standing Fire Advisory Committee, Examiner and Paper Setter for BE, Fire Engineering, BSc Fire, Advanced Diploma, etc. Technical qualifications include Member of Institution of Fire Engineers, UK, Fellow of Institution of Fire Engineers in India, Fire Protection Diploma in UK, courses in Japan, in US, and Thailand, and awarded the President's first service medal for meritorious services in 1999, and President's Fire Service Medal for distinguished service in 2006. Thank you so much, Dr. Shami, for joining us, sparing time to share your knowledge and your expertise with the audience who have joined us from various parts of the country. Over to you, Dr. Shami, for your intervention.
Thank you, Rubab, for very nice introduction of me. You know, rather I am speechless after listening to Dr. Yogender. I told you that I am not ready with my PPT, and after seeing his PPT, I think it is better not to speak anything with the slides. Dr. Saab, you have prepared a very rich slides. My compliment to you. You have done really hard work. Actually, Majumdar told me only yesterday, and I said it is difficult to prepare something in a very less time, because as a platform like FICCI, you should be more, prepared with your emanation. So presently, I'm not very much ready, but since I accepted the challenge, so I try to do something more or less. But you know, our two initial speaker during the inaugural session, they talked much about the fire safety, but I don't know why everybody is mixing this fire safety with the disaster management. And you know, slowly this disaster management gambit is taking over the fire protection. Everywhere I keep on telling that you have to give the special consideration to fire safety, because you know, once you built everything, and any failure, it's nothing but for failure of anything, it's a fire accident, a fire disaster is the result of it. So we should think in advance. We have to think proactively. So for other things are concerned, I'm sharing my little bit presentation. So allow me to share for it. Okay. Right. I'm audible, Mr. Sood?
Yes, you are, sir.
Okay.
Yes, thank you.
Right. So anyways, of the small presentation, I'll finish up soon, because after 4:30, I wish not to start firefighting with all this audience, though they are sitting at home, but we have. I started digging up that on which particular topic you want me to speak, because industry is a very vague term. And as such, if you start searching for any standards on the industry, any write-up, any code of practices, you won't find it. Industry is a very vague terms. So, but I tried to collect, you know, our 10 leading industries in India, like textile industry contributing 2% of GDP, at the same time creating a lot of fires also. Similarly, the pharmaceutical industries, though it is growing day by day, but you know, the small fire can convert the entire industry into the big blaze. And then you talk about the automobile industry, chemical and other industries all. Of course, then this engineering industry is also contributing, along with FMCG, education training institution, tea industry. So by going through this 10 major industry, you can understand that the problem is entirely a different, a unique. You cannot frame the standard framework. You cannot come out the formulation of one standard for all this kind of industries. You have to see a little bit more. Though National Building Code of India tried to address the issues pertaining to the industry, but still they have to go a long way. The document, which is the Bible for all of us, including what Mr. Yogender Singh was talking about, the earthquake safety. You know, the National Building Code of India is very rightly addressed to it, and thanks to the Roorkee, they have contributed a lot. Dr. Yogender also talked about the performance-based design. There is a lot of controversy going around in the fire safety industry amongst the fire engineers and the fire professionals, whether we should go by the performance-based design or we should go by the prescriptive design. I, as a fire advisor, concluded that, look, we don't have a expert like Dr. Yogender. I mean, he must be very lucky that he has got a vast knowledge. But I'm a little bit worried about the condition of a poor India. I don't know how many of us can afford a expert engineer like Dr. Professor Yogender. So there is a difficulty that every time we cannot hire an expert engineer, architect, designer to give the designs from the performance base. So I, as a fire advisor, I am a chairman of so many committees in our Bureau of Indian Standard. I thought, no, it is better to go for the prescriptive and provide the minimum prescription and leave to be on the fire officer or fire engineers to think much on the other aspects of it. If they want to go for the performance, they can definitely go for it, but they should go with the minimum prescriptive one and then follow the performance based, because in the performance based kind of a design, all factors you will see, I mean, they are the different for the different perspective, and it's keep on changing, and the condition of India is so volatile that you cannot design based on the performance based. Anyway, this was my conclusion for my own standards, and we have decided to go with the prescriptive type of a standards. And though we are supporting to our engineers, they are vibrant, they are coming up with the all new sort of the ideas, and we are welcoming that. But to help the poorest people of the India with the ready-made solution, we are still going with the prescriptive type of standards. Now, just for your kind reference, because our two previous speakers have also mentioned a lot of disasters in India. So the major industrial disasters are this Bombay Dock Expo 1944. Based on the 1944 disaster, no, it's basing its disguise. Other fire services, started observing 14th April as a fire service day and fire service week. And because of that disaster, on particular on the 14th of April, at least since 1968, Government of India is pushing to celebrate and observe that those day and week as a mass awareness week. You must have seen some of the fire officers keep on coming to your industry and asking you to just organize some mock-up drills or some lecture or something like that. So because of this particular explosion, and because of the huge losses, we started observing fires on that day. We lost 66 valiant firemen on those days, a single day. Then there are other disasters also. You must be aware of this mining disasters where a lot of people have lost their lives. The Union Carbide, the Major General, he himself has quoted all this. Then Korba chimney collapse, Jaipur oil depot. Everybody is aware about the oil fire depot of the Jaipur. And after that, the Lal Committee has suggested to have a regional response centers with the petroleum and other sectors in the industry. Though since his recommendations, still those recommendations are pending, and we have not been able to see the day when our regional response centers for the oil sectors company will work. So still we are waiting for that. And the Visakhapatnam refinery. There are so many other disasters also. I mean, you must have gone through it. There is a lot of history. But you see, in whatever the disaster mentioned here, the fire is the outcome of failure. Fire is the outcome of a failure of engineering design. Fire is the outcome of something which you can say poorly designed, or because of the fault of man. So if we'll follow the standard procedure, if we'll follow the standard practices, if we follow what has been prescribed in the standards, if those practices are not prescribed, we can develop as a SOP. And if we follow all those SOPs, all those standard practices, I think we could have saved a lot of lives and property. So this was just something about the Indian side of it. But you see, if I go the industry wise, if you'll focus on the defense industry, so you'll see a lot of fires in the defense industry also. You can see the fire in the energy industry also. So I said that industry is a very vague term. If I try to focus on the defense industry, it is highly explosive industry. It's a highly hazardous industry. So for those kind of industry, I have to prepare a different set of standards, different set of recommendation, different expertise is required. If I start focusing on the energy industries, starting from, you can say, the various kind of a power plant like thermal based, nuclear based. Mr. Bhartwas talked about the nuclear based power plant. I was just laughing because I worked 6 years in the nuclear power plant, so I know the preparedness is purely based on the atomic energy guidelines, and they think ahead of a time. This is based on the international and other exposures, so they keep on adopting the latest practices all over the world. So their thinking is, I think, ahead of a time, and with the cooperation of international agency, they're always thinking ahead of it. So you think of a atomic energy plant, then hydel, there's solar and wind power. So everywhere you see the different types of power plants are there, and you cannot implement a single recommendations to all. You have to read, you have to understand the hazards, and within that particular type, you have to understand the what all others related items or the process is being carried out. So by understanding the entire industry, by going at a micro level of the equipment procured, equipment provided, process being taken inside of that particular industry, you cannot give the right kind of recommendations. So it is difficult. And then see, the fire accident in the food industry also started taking up. They have the different kind of a gas plant. They have a different kind of materials which are being used. The manufacturing industry and the mining industry. Mining, of course, is another typical area. It is not being covered under so many, the industrial fire. Mining, they consider is a different one. And as a general disaster, if you'll see that you will find the rail accident and other accident, which are if some explosive is being carried out by this wagon, and if they met with some accident, they met with some accident. So you'll see that the outcome is again the fire. And after that fire, you'll see a lot of loss of life and the human and the property also. So after considering this latest fire in the thermal power plant, and after emulating the 13-14 acts on the occupational safety and health, like Factory Act, Dock Workers, and the Building Fire Acts and other thing acts, the Ministry of Labor has decided to go ahead with a kind of a standard which is applicable to all these places uniformly. If you'll, if you are in the industry and you are aware that either you are going with the Factory Act recommendations, which are prescriptive in nature. Those recommendations are very prescriptive. They generally guide the occupier or those who are there as a responsible man, that you have to adapt the fire safety measures. But what type of fire safety measures you're supposed to adapt, you are not clear. So those kind of a thing, it was continuing since 1948. But now ministers decided to have a standard for the labor ministry also, and they formed a committee. This committee is chaired by me along with a lot of eminent persons in the industry, right? Mr. Lalit Kabane is a DG National Safety Council, and then from the FICCI, DG FICCI is supporting Mr. SP Garg, who worked in the GAIL. He's one of the member, TRA Krishnan. Then you must be knowing about Mr. Hirak Datta. He's expert in the OSG standards. So the 13-14 experts, they called and requested us to frame the standards which will help the entire factory. And to my surprise, when I started thinking of this factories, that what kind of a factories are available in country, and what type of standard I should give them. So to my surprise, nobody has even categorized the various factories as a low hazard factory, medium hazard factory, and high hazard factory. And based of the requirement, the chief inspectorate is keep on giving the recommendations for the fire safety. It is a very general, very vague the recommendations. You cannot make him accountable for his over designed recommendations, or you can say the under designed kind of a recommendations. So keeping in view of all those available practices, I thought that there is a necessity to formulate a standard which is applicable uniformly for the low medium and high hazardous industries, as well as this factories kind of a thing. Now, this industry things I will cover up later on, but for the factories, we have decided to go ahead with the various vibrant kind of a recommendation, which is applicable for all, and all my 13 members are working very hard to ensure that they will give something very good standards, like a code of practices, which will be applicable for under the Factory Acts, and through that, in the future, you will see the uniform recommendations at pan-India level. Though the Secretary Saab said that, Shami Saab, you don't have to over prescribe the fire safety measures. I said, sir, it will not happen. But of course, until and unless we standardize, until and unless we classify the industry based on their hazards, the chances are there that we can underestimate or overestimate our recommendations. So then finally he agreed for this, and then this team is working. We have given the 6 months to formulate the standards, and after that probably you will see that we will have the good standard on that. The team is working very hard, and you are aware about this Factory Act, that as per the provision, what all we identify as a factories, and this is the place where the small big accidents taking place. So they have given us a different various provisions of factory, and then the clauses under which they're supposed to take care of fire and other safety precautions and the measures. And these are so descriptive that anybody can manipulate it. So under these provisions, we have to go for the new standards, and we are thinking of doing it in a very limited time, And now I'll just focus it on the industry, since my today's topic is mostly on these industries. And as I told you that for this industry, we don't have any Bible, we don't have any standard document. You cannot rely on a single document. You have to study all the industry from all perspectives. You have to see what all kind of equipment, all kind of process they are being followed. Until and unless you study with your own, until and unless the experts study, they cannot give the proper recommendations. And after only studying the hazards, they can then provide you the recommendations. But what the NBC has done, they have gone through the various type of a classification of industry. The National Building Code of India has mentioned, the 9 type of a classification, and this industrial stand at the group G level. We call this as a and these groups are building used for low hazard industry, then building used for the moderate hazard industry, and building used for the high hazard industry. So this standard criteria, if we'll apply on the available equipment or the process being carried out, probably we can come out with some solution. And National Building Code of India has in fact attempted a very good thing, and then they have prescribed the minimum requirement in the industry. Though this particular requirement is under the review by the committee set up by us, and they are probably very soon will provide a standard document out on industries also, So for determining the hazards in the industry, they generally calculate the fire loads. And based on the fire loads, they determine that what kind of fire load based on the calorific value is available over there, and based on that, they divide the industry into the low, medium, and high hazards. Then, as I told you that further we have divided the industry into the 3 subdivisions. G1 is the low hazard of a thing, and you can see that what all kind of a thing is calculated as a G1, then G2, and G3. So these are there in the National Building Code of India. I think you can see this. You can refer the National Building Code of India is very much mentioned over there. So I thought that I will share this information with you. Now, the very important factor in any industry is the travel distance. We keep on building the various blocks. We keep on building the big halls, but sometimes we forget to calculate the height of the building, and second, we forget to give the travel distance. because in the fire safety, the one of the basic, law is that if something went wrong, you should get out safely. For your evacuation, we are mostly concerned. So if we are concerned for your evacuation, so you should take care of your travel distance, because we calculated this travel distance based on your speed of egress. I mean, the time you take to get out from the remotest area. So for the industry of a G1 and G2 type of type 1 construction, type 1 and 2 is basically, for we can consider it as a 4 hours and the 2 hours rating construction. So we considered to travel time is almost 45 fits to 22.50 for G3 category of the industries. So for high hazardous industry, the travel distance is late 22.50 thing. So this is the factor which they have categorized in the National Building Code of India. Besides the various things which you can see, that whether you should provide the fire extinguisher. If yes, then what kind of a standard you should follow. If you are recommending to have the fire extinguisher in the industry, then there is a standard 2190. 2190 very critically, after evaluating the hazards, specify clearly that how many fire extinguisher and what type of fire extinguisher is required. So this particular chart of National Building Code of India, table number 7. If anybody want, they can quickly refer this chart for their references also. This chart clearly gives you that whether you should have the fire extinguisher, whether you should have the hose reel, whether you should have the sprinkler, whether you should have the detectors to detect the fire, and if you should have the detectors, and then for detector you should again follow the Bureau of Indian standard of selection and installation of various detectors. So you have to then identify the hazard, you have to identify the risk, you have to identify the what best kind of a detector system will work to detect the fire in advance. And this detector then linked up with the extinguishing mechanism. Like sometimes they linked up this with the flooding system, sometimes they linked up with the mist technology system, sometimes they linked up with the water deluge system. So this kind of a system is directly linked up with the detection system. And in the server kind of a room, it is mentioned, if a server type of situation is there in your industry, you should follow the inert gas system. And this inert gas system has to be a double protected system. You cannot actuate the inert gas after getting only first alarm. That delay system is there. We have to consider the human time travel, human presence over there. So this kind of a detection system is very helpful in actuating things. So National Building Code of India has categorically said about what type of a system you require. What is the distance for the fire hydrant? What is the distance for the hose reel? What is the distance for your fire branches? So the moment you start referring it, they have given the thumb rule for the entire industry. And whatever the fire system you are seeing in the industry, it is outcome of National Building Code of India. Though they are not following the National Building Code of India, which is updated in 2016 and published in 2017 March. Though they are not following strictly. So we are trying to push this after revising this table further, befitting to the requirement of a various industry. But I am still worried that how the various types of industry we can include in the National Building Code of India. Either we have to have a different code. Like, I'll give the example of OISD. OISD has given the specialized recommendations for the petrochemical industry.
Doctor, your slide is not visible somehow. I don't know. Can you please, share it again? Can you just...
Okay.
And can you stop sharing and then share it again? Maybe it has got stuck somewhere.
I'm sorry.
Sorry to... No, it's not your problem. It's sometimes it's the connectivity issue. So it happens. It happens. It's a normal thing. Just unshare.
Give me just a minute. I don't know whether... Now it is visible. Just
yeah. It is.
So this one is visible. So actually, I was talking from the link slides. So perhaps because of that particular link, it may not be visible, and
perhaps could be. But then now, can you move
up to this level?
Yeah. Up to this. point we saw it. Yeah.
Okay, that's fine. Fine. So I will just talk about all this. Actually, I tried to click the hyperlink, and perhaps this hyperlink is not working so far.
No problem. No problem at all. Please
Anyway,
carry on.
so I was just I told you that I'm very poor in this sliding system, so I'll just keep on talking with whatever something in my mind. So I told you that the national OISD, they have done a wonderful things by publishing the OISD standard. And Mr. Sood, you are, I think, much aware of the OISD standard, because once you saw in my CV about the OSD committee, you especially mentioned that that who is the leader of the OSD, and you rightly corrected that. Now the peso, they have converted that OSD as the name. But those standards, I really suggest everyone that one should follow them. Hirak Datta has contributed a lot, besides a lot of engineers, and I think perhaps a lot of engineers and scientists are attending this one, those who have contributed in the OSD standards. Very wonderful standard. I must say that industry should have the specific standard, like thermal, like the power industry. They should think of having the separate standards. So actually I am here not to just waste my time, rather I am here to invest my time in FICCI. FICCI should take the lead, and FICCI should ask the leaders to form a committee, or FICCI should form the committee. This is a task I am giving to FICCI, because the type of a handbook is required. For the various industry. Of industry, sometimes ask us to provide the specialized thing. So like OSD, like what the petrochemical industry has done, FICCI can take lead to ensure that the various type of industries should have their standards, and if not, then at after 6 months, you will see the specialized standard and codes for the labor ministry also, to address the factory act itself. So these are the things which if you follow, you can improve it. And like Dr. Yogendra also talked about that structural and the non-structural issue. You cannot achieve fire safety interlinked different and the various chapters with the National Building Code of India Part 4. I am a custodian of a Part 4, being as an advisor to the Government of India since 1994. I started pushing to ensure that that National Building Code of India Part 4 should be implemented through the State Fire Service Act. And I am proud to announce that more than 25 states has implemented for with the other parts of the National Building Code of India, like Part 3, Part 8. Part 8 is talking about the services and other things. So and structural safety Part 6. So directly and indirectly, they linked up with the various part of the National Building Code of India, and through this implementation through their State Fire Service Act, their fire service, ultimately they are implementing the recommendation of an by forming the committee for standardizing the standards. Once we interlink the available best standards in the country published by the Bureau of Indian Standard, OISD standard, if we interlink at the proper place, this standard will become the practices for the labor ministry also, and all those recommendatory standards will become. And they just want to for industry. I still feel pity for them, because though they are the leaders, they are contributing a lot, and a simple loss to them is a huge loss for the country. So we as advisor, I mean, always trying to see that they should have something as standard practices, and they should have the standard practices based on their group. a different kind of a group. If not, then we can have a code of practices based on the low hazard, medium hazard, and the high hazard. I'm totally focused all this my talks towards the fire safety perspective, though disaster management is a part of it. And I said it, any failure, the outcome of any failure is a fire disaster. So we are at the end of it, and we poor people are keep on bearing the burden of it. Thanks for giving me the opportunity. I am open for any question. I have not included much. I have a time because I have taken much less time than any other speaker. So I am open for any question if they have.
Thank you so much. Thank you. Thank you, Dr. Thank you, Dr. Shami, for sharing your rich experience on this subject. And I think although the number says it all at some points, 35 years, but then it's what we saw was much more than that and much more enriching. Thank you so much for that very informative talk. I understand Dr. Yogendra Singh ji, he has a hard stop and has another meeting at 5. Thank you so much, Yogendra ji, for your contributions today.
Thank you.
I will just quickly ask Professor Gupta to make some concluding comments based on the presentations made by both of you. Over to you, Dr. Gupta.
Thank you, Ruab Saab, and thank you, Professor Yogenji and Sri Sami Saab. In fact, both the speakers they presented in such a way that it was not in fact a webinar. It was full lecture and very much details. Professor Yogendra Saab did not discuss only the technical dimensions, but also brought in a lot of dimensions related with understanding the damage potentials. And I think that is very important understanding, because when we are talking about this paradigm shift, we need to bring the industry management on board, and they need to realize that this is a serious challenge. So very nice articulation from his side. And Sami Saab, his recommendation of some kind of a manual or handbook. In fact, these kind of when I look at these suggestions, manual or handbook should not be very bulky. But I think a few pager document on earthquake, few pager document on fire safety. I think these few pager documents can really work very well. It can enlist the important codes and standards. It can enlist the important resources which they at the planning stage should be referred. So I think these kind of information may be very useful. And as they suggested that FICCI can take up this initiative, and if required, an IDM would be happy to join hands with this. This discourse has been very useful. I think very important points have emerged as a kind of a takeaway lessons from these two lectures. And it tells that from the planning stage itself, when we plan for an establishment of an industry, so from beginning itself, these issues are required to be addressed. So this is very important lesson, because yes, we can try to reduce the risk at later stage also, but it will be always beneficial to consider these issues from the beginning. So very important lectures, and I hope that this discourse has been very successful. So over to you, Rubab. My compliments to the entire team.
Thank you.
Thank you so much. Thank you, Dr. for your concluding remarks. And I think you complimented both the speakers in a very in the right manner, something what we were thinking. I think this was more like a discourse, as you said, more like a full session, like we've had it's more like a training than anything. And that's something what we couldn't, we couldn't have asked for more. I think this is something what we were desiring for, and I think we've got more than we wanted. Thank you so much, Dr. Shami and Dr. Yogendra, who's just left us for another meeting, for sparing time. And I know we've skidded past the schedule, but we see the interested participants, almost 215 number. They're still with us, and they've made, I think, hopefully made the most out of this opportunity they got. Akhil, if you are there, would we can we just quickly see if there are any questions for Dr. Shami? For questions regarding related or pointed toward Dr. Yogendra ji, we would take them, from the Q&A box, and we'll email it to him. And he said he'll be happy to answer those questions, and we can respond to those questions individually to the people who have asked those questions. So meanwhile, if there is any fire related intervention,
I don't see any question as of now, but yeah, we have certain questions for Dr. Singh, Dr. Yogendra. We have certain questions. We will email the questions to him. He sent a message to me. Yeah.
Yes, they were more on, but there were so many comments, Dr. Shami, in the chat window. If you see yourself, there are so many comments. People are really pleased. They have seen you on many platforms, especially over the past 1 year. On one of these fire safety related capacity building workshops. But they were very pleased that we have also been able to get fit into your schedule. So thank you so much, Dr. Shami, for sparing time and joining us today. It was an absolute pleasure. I remember meeting you and seeing you in July 2019. Manak, was it then?
Yes.
July 2019 at Taj Hotel, when you had come from the CIDM conference. That was the last physical meeting we had. But I'm sure those times will come back. वो कह रहे हैं कि ये समय नहीं, वो समय नहीं रहा तो ये भी नहीं रहेगा. We'll soon meet again, and in person, and we'll discuss more on this subject for you, on which you've mastered and you've pioneered for over 35 years now. So I think on that note, friends, Dr. Shami, Harshit, I think we can say goodbye for the day.
Thank you very much.
Very, very fruitful session.
Thank you, sir.
Thank you so much. Thanks to NIDM. Thanks to Bhardwaj, FICCI, CIDM board chairman, Dr. Ahmed, and all the others, Akhil, Menak, Varun, Dr. Gupta, and Major M.K. Bindal from NIDM, and of course Harshit, the force behind this from NIDM side. Thank you, Harshit. Okay, bye-bye. Thank you so much. All of you, please stay healthy, stay indoors. It's a matter of few more days. We'll all be, situation will all be good, and like it has improved in Delhi, Bombay. My thoughts and my prayers for cities like Bangalore, which is really in bad shape right now. But like we have fought it out in Delhi, I'm sure Bangalore will do the same, and we'll all have a COVID-free environment very soon. Thank you so much, ladies and gentlemen. Bye-bye. Take care.